Yeah.
Hello, good afternoon. My name is Hakim Adedeji. I'm a teacher, science teacher. We'll be doing something on science bites. This topics, this series is for children that are preparing for their GCSE and general any secondary school pupil that's interested. The topic we're going to treat today is alkanes, and our learning objective is to define what alkanes are. Alkanes are saturated hydrocarbons. Now, for GCSE, this is a very key definition. Saturated hydrocarbons. They might ask you what are hydrocarbons. Hydrocarbons are compounds that contain hydrogen and carbon atoms only. Very key. Hydrogen and carbon atoms only in their molecule. So these are compounds that contain just hydrogen and carbon atoms only. Now, what are alkanes? I say alkanes are saturated hydrocarbon. When they say saturated hydrocarbon, what that implies is that for a typical alkane, they have this structure. This is the simplest alkane. This is methane. Now, if you notice, the carbon atom has a single bond in between it and the hydrogen atom. Or better still, if I do this next one, the second one, which is ethane, this is ethane, and this is methane. Now, the reason why an alkane is called saturated is because of the single bond between the two carbon atoms. So, because of the single bond, that is why it's called saturated hydrocarbon. The single bond between the carbon atom, is the key thing. Carbon atoms. So that is why it is called an alkane, because of the single bond. Now, alkanes, they are saturated hydrocarbons. That is, because of that, they are not as reactive as their fellow hydrocarbons, the alkanes. Now, with the single bond, they have a general formula. So, we know they have single bond between the carbon atoms. So, key definitions are saturated hydrocarbons, single bond between the carbon atoms, they have a general formula of CnH2n plus 2, where N equals or greater than 1. So they have a general formula. So what are the key characteristics for the C grade? We should know the general characteristics of alkanes. They have a single bond between the carbon atoms. They have a general formula of CnH2n plus 2. So you could be asked for your specification, you should know the first five compounds. So how do you calculate that? How do you know which compound is which? For the first one, if N equals 1, that means it's going to be C1, because N equals 1. N equals 1. That means C1, whatever you see the N, you substitute it with 1. That's what it means. So your math skills also comes into question there. So C1, H2, 1 plus 2. So that will be C1, 2 times 1, that's 2 plus 2, 4. So it's going to be C1H4. But in science, or basic chemistry, we don't put the 1 there. So we just ignore the 1, we just write CH4. So the second one, If N equals 2, that will be C2H2 into 2 plus 2. So that will be C2H6. Now, you will be required to do, so you can do the rest yourself. So N equals 3, N equals 4, and you'll see a pattern. So this is methane. That's the natural gas you use for cooking. And this is ethane. C3 will be propane. So C3H8, C4H10, and C5H12. So this is propane. This is butane. And this is pentane. Now, if you notice, the names you get is indicative of the number of carbon atoms. Met means 1, eth means 2, prop means 3, but means 4. It gets easier because now your math skills, if you know C5 is pentane, C6 will be hexane. If you've done your mathematics skills, I mean, remembering the shapes, number of sides in the shape. So that is that about that. Now, what else would they ask you apart from, we now know that the formula, going back to what we started before, the single bond between the carbon atoms, they have a general formula of CnH2n plus 2, n equal or greater than 1, and I've given you examples of what they look like. Now, drawing the structure of alkane, that's where we're going to. So I've drawn the structure on the board for you. So we know the easier one. So propane will be, first of all, draw out, the key thing is draw out the carbon atoms first when you're drawing the structure. You need to draw the carbon skeleton, because that's what everything will rest on. So I've done my carbon, and my carbon, very clumsy carbon there. So that is where you start. Now, you need to understand, carbon is bonded because it has 4 electrons in its outer shell. So it needs 4 electrons to bond, to make it an octet state. So make it octet. So you get both. So it's 1, 2, 3, 4. So you need to start. The key thing is make sure your carbon atoms. Mine's a bit clumsy. Sorry about that. Make sure your carbon atoms and hydrogen atoms are. Make sure the bond is shown. Please, there are some students that make this mistake. They take off these bonds, these lines. This line indicates the bond between hydrogen and carbon. If you don't put those lines there, you are not actually doing yourself justice. So please try as much as possible to make sure the bonds are there. So this is propane. There will be a structure of propane. So you can do the rest yourself. And lastly, what chemical reactions? They actually, because the hydrocarbons, the alkanes, they actually basically, most of them actually used as fuel, because they have, when you burn them, they produce a large amount of heat energy. So they are used as fuel, and they undergo what's called combustion reaction. When you burn a substance in oxygen, you have what is called termed as combustion reaction. So for an hydrocarbon, the word equation is alkane plus oxygen will give you carbon dioxide plus water. A good example, propane, or in most cases, ethane or methane, whichever one of them. Methane plus oxygen will give you carbon dioxide plus water. So I can do this for higher level. I mean, for the higher paper, you could be asked to write the chemical formula. Even the foundation, they might go as far as that. So ethane is okay. Let me give you an example. CH4. So this is methane. This is the one we have at home. The gas you use for cooking. That's a methane gas. The one you use in your labs or for the Bunsen burner. Let me write this properly. So this is what we have. So methane gas plus oxygen giving you CO2 gas, giving off plus water from steam. So this is how you now need to balance the equation. And I have one carbon atom here, one carbon atom there. I don't have a problem with carbon. I have 4 hydrogen atoms here. I have 2 hydrogen atoms here. I have a problem with the hydrogen because 4, 2, not balanced. And I have 2 oxygen atoms here, I have 3 here. So I need to balance the hydrogen and the oxygen. So if I put a 2 here, so that will be 4 molecules of hydrogen for 2 molecules of oxygen there. Because this 2 will cover both the hydrogen and oxygen. So I have 4 hydrogen molecules here, but I have 2 oxygen molecules. And I also have 2 oxygen molecules. So 2 oxygen molecules plus 2 oxygen molecules will give me 4. So the next thing I need to do is to balance up this one, which is 2 oxygen molecules. So I put my big 2 here. So that will balance it up. So if you look at it, this is an example of a combustion reaction. So we call it a day today. Tune in next time for the next series of Science Bites. Thank you very much. Bye.